Today's discussion is on replication in MongoDB. So what is replication? We have seen this definition many times, but again let us recollect. What is replication? It is the process of synchronizing data across multiple servers. Or in other words, we can say having the same copy of data in multiple servers. So replication provides redundancy and increases data availability with multiple copies of the same data. So I have got a visualization for you here. Say we have an application and it reads and writes data to a database server. And say this is the data, name Satish and some balance of 100 rupees, yes. And we call that to be server A. And this data can be copied or replicated to two other servers in two different locations. So the same data you see here, whatever data that is coming into this server gets copied to other servers. We call that process to be replication, copying data and maintaining multiple copies of data in different servers. So what is that we get? What are the advantages we get by this? We get fault tolerance. For instance, if one of the nodes here goes down, fails, then the application can read and write data from another node. That is one thing. And another important thing we achieve is we get data redundancy, thereby we can read data from multiple servers. At the same time, parallel reads can happen, so it increases the performance of your reads. So this kind of a process of copying data is called replication, and we are going to see how this supports, how replication is supported in MongoDB. Before even going into that, what are the advantages? High availability, no downtime for maintenance. So we always have some server wherein we can read data from. Read scaling, extra copies to read from. So these are the advantages of replication. So when you talk about MongoDB replication, it's something of the same setup that we have just now learned. So we have an application. This will read and write data to a server. This is the main server. You call that to be the primary server. And the data from here can be replicated to other servers. They are called secondary servers. Or in other words, replica servers. So when you take a closer look at this, the application can read as well as write data only from this primary server or the master server. It cannot write data to the secondary servers. It can only read data from the secondary servers. So this is the concept, and you call this entire set of servers that maintain the same copy of data, you call that to be a replica set. In MongoDB, these three servers that maintain the same copy of data, you call that to be a replica set. And what each server means, it's a MongoDB instance. It's an instance running, or it's a MongoDB process that takes care of maintaining the copies of the data set. So each one is separate MongoDB instance. So you have to run many MongoDB instances then. Okay. Another important thing that is supported in MongoDB replication is if the primary server to which the application writes data fails, can fail due to a network issue or an hardware issue. So when it fails, what happens is an election happens between the remaining two servers, and immediately a new primary gets elected. Say for instance, this can be elected as a primary, and from then on the application will start writing data here and reading data here, whereas this will act as a secondary. So when this node that has gone down, when it comes back again, it can join the cluster as a secondary server. So that is the concept, and it offers fault tolerance and multiple reads can happen. Okay, are you all clear with this? So what is a replica set? It's just a group of servers that will maintain the same copy of your MongoDB data. So some definitions here. What is a primary server? In Neo4j, we have looked at core servers, right? Same kind of concept. So primary server receives all write operations, and you can also read data from a primary server. A replica set can have only one primary server. So we have looked at the three servers, right? Out of that, only one can be a primary server. The primary records. Okay. So this one says, whenever you make some changes to the data on the primary, what will happen is the changes will be carried on to the secondary servers using this log file called oplog, operations log. Let me go back to this diagram. Let me show you what that is. I have some data here. Application reads, modifies data, writes data. So when it goes and modifies this to 200, what it does is it has a log file. It's a collection to which it records the changes. The other replica servers asynchronously, gets the updates from the log file and applies those changes to the instances. So that is the meaning. So every change that's happening is entered in an operational log in the primary. What is a secondary server? Secondary server is only used for replicating and reading data, and even for reading data you have to configure such that it allows reading data. So secondary servers replicate the primary's oplog and apply the operations to the data. If the primary is unavailable, then an eligible secondary will hold an election to elect itself as the new primary. What is a replica set? A replica set is a group of MongoDB instances. MongoDaemon. A daemon is a process that runs in the background. So this process is responsible for maintaining the data for your Mongo database. So it's a group of MongoDB instances that maintain the same data set. A replica set contains several data bearing nodes. And out of all these data bearing nodes, only one node is designated as the primary node. Okay. Is that clear? What is this oplog or operations log file? It's a special collection. It's again a capped collection which will be overwritten when the memory is full or it runs out of memory. So it's like operations log is a special capped collection that keeps a rolling record of all operations that modify and data stored in your databases. MongoDB applies database operations on the primary and then records the operations on the primary's log. Just now we have seen any changes will be recorded in this file called oplog, collection called oplog, and the primary will perform that update of the oplog. The secondary members will copy the oplog file and then they will make those changes to the data in their servers. Okay. So replica set in MongoDB, I'm going to show you a demo of how replication of this sort works in MongoDB on a local machine. So I'm going to use my laptop, show different instances of MongoDB, and we are going to use MongoDB here, right? So the primary MongoDB instance will be using a port number 27018. So it will be listening to requests from the application in this particular port number, and that will be my primary MongoDB. And the other two secondary servers are two separate MongoDB instances which will be listening in these port numbers 27019 and 27020. And what do you mean by a MongoDB instance? You can actually connect to a MongoDB using a Mongo shell and communicate with it. That's the concept. And oplog, as I told you, whatever changes you make to the primary's data will be logged in the file, the collection, and that will be used by the secondaries to update their data. Now, what we are going to do is we are going to configure 3 MongoDB instances in the local machine, and then we are going to use Mongo shell for communicating with the MongoDB instance. So I can use Mongo shell, I can create a document, insert document, read documents from the primary. Whereas the same Mongo shell can be used for only reading data from the secondary. If I try writing data to the secondary, I will get an issue saying it's not the primary. Okay. A replica set can have how many members? I didn't really update this to a thing. I didn't go and verify MongoDB is documentation on whether they have increased the capacity. So you can have 50 copies of the same data. That is the maximum capacity. But anyway, I have to verify that. But you can take that for now. So what happens on failure of a primary node? Say if you have primary node, what happens when the node fails? An election happens, and then the secondary gets selected as a primary. So how will you know whether a node is active or not? How it knows is it uses this thing called an heartbeat. They say it's a ping. Now every server pings every other server for a given within a given time. The server is not responding. Within a few milliseconds, I'm pinging a server is not responding. Then what I assume is that server is down, and then I'll go in for an election with the remaining servers, find a new primary. So the election of the primary happens automatically within a few milliseconds, and then it will respond to the application's queries. Okay, that's what they are saying, and it's a thing that you can configure. Election timeout milliseconds period is something like 10 seconds by default. I ping a server, I don't get a response within those 10 seconds, then I go in for an election. You can go and configure that. Okay. See, there is one more thing. When the primary fails, when the election is happening, still a read can happen from the secondary service. It supports read till the new primary gets elected. So we'll go with demo on replication on a local machine. So how this demo is going to be is, we're going to configure 3 MongoDB instances in the given port numbers, and then we are going to run some queries and create this replica set, and then we'll see all these things. So I have created a document for my replica set creation. The first thing that we have to do is we have to go to this folder. I think we have to go to the bin folder and open command prompt. Go to the bin folder. Have that ready. Okay. The first thing that we have to do for this exercise is we have to create 3 directories to hold the data for all your replica sets. So where will you create those directories? You go to C, and then you'll find the data folder created for MongoDB. So let me go to my C drive. Let's check whether I have that folder. So C drive, and then you can go and see there's a data folder created when you go and install MongoDB. So here you have to create 3 new folders. So you just go and have a new folder, and you can give any names for that folders. I am just giving RS1 to say it's Replicaset 1 to store data for the replica server 1. And like that, we have to go and create 2 more folders for Replicaset 2 and Replicaset 3. RS3. Okay. So we are done with this, and what we are going to do now is we are just going to our command prompt, and let's check our file. What we have to do next? We have to start 3 MongoDB instances, and this is the command for starting that. We have to go to the bin folder first. I'm already there in my Mongo bin, and then I'm going to run these commands. Start MongoDB will start an MongoDB instance, and REPLSET, that is the replica set name I'm giving. I'm giving the replica set name to be Satish itself, and log path is the path wherein that log files for this replica server will be stored. That is nothing but in the data folder, RS1 folder, I'm storing the log path. DB path is where the data for this replica server will be stored. It's again data RS1. And next command comes in port number. In which port number this instance will be listening for request from the application. So you give 27018. So that's how you start a MongoDB instance. Let's just go and run this. Copy this command and go to your command prompt, and then you copy this, press enter. So here there is a MongoDB process that starts up, and it's running in the background. So where it will be listening for request in port number 27018. But how many replica servers we have? 3. So we'll start another 2 servers too. So start MongoDB. Replica set name is the same because all these 3 servers come under one replica set. and the log path will change. This is RS2 and RS2 for DB path and log path. The port numbers will vary according to our configuration. So let's go and run these two instances. So you should get a window like this and it should stay there. Only then your process is running. If this window just comes and vanishes, it means the process is not fine. So you have to check. Okay. And the third server is again, it's going to listen in 27020. So we'll just, yeah, we have 3 MongoDB instances running in the backend. And what next we have to do is, we have to go and configure a replica set. That is, we have to connect all these nodes and form a replica set. For that, we have to go to this particular port 27018. So what I am doing here is, I am just going to consider the very first thing that is running 27018 to be the primary. And I am going to consider the remaining 2 instances to be the secondary. So I am going to connect to the primary. How to connect to the primary? I just go to the bin folder and then I just give Mongo and then the port number. What is the port number? 27019. So 27019 or 1818. So 18 is the primary port number. So now I am using the Mongo shell to connect to the MongoDB process. So it says it has connected. You can see here, connected to 27018. So in this primary, I have to run certain commands. So let's go and see what those commands I have to run. After connecting to the primary, what you have to do is, you have to run this command config, which just groups, okay, what are those IDs and hosts that will be connected together as a replica set. So we just say replica set name is Satish and the members are these members. So just copy this and then you create that, run that in the primary. So you have to get an output like this. So it says ID 0, host ID 0. These are the members in the replica set. Just a configuration command, copy and paste it. Don't think too much on all these things. Once when that is done, we have to run another command called rs.initiate configuration. So we'll run this command. So we are working with the primary here. All these things should be run on the primary. So once when you initiate configuration, you should get OK 1. Okay. Initially it says secondary. Don't worry, it will turn it itself into a primary. So once when that is done, you have to just go and give rs.status. Check the status, something like that. So rs.status. Yeah. So now when I give the status, you can very well see the status here. It very well tells you the status. It says localhost 27018. The status is primary. So we configure that to be primary. And it also gives the status of other members. 27019 is nothing but it's a secondary. And 27020 is nothing but a secondary. So you get the status and you now see it changes itself as primary. We are working with 27018 instance and it is now configured to be primary. So once when you are connected to the primary, what all you can do with the primary, you can read and write data from the primary. So let me go and just say show DBS and let me say use Satish DB. Let me create a DB here. I am writing data to the primary and there are no collections. Let me create a collection db.student.insert. Let's insert a record in the student collection. Name will also be Satish, or we'll say from primary. So I am inserting this record in the primary, right? Everything. We have performed all these operations using the primary instance. Now what next we have to do is, we have to go and check the secondary servers. We'll just connect to the secondary server. How can we connect this? We'll open another command prompt. Let me open another command prompt. We have to connect to the secondaries. In which port number secondaries are running? 27019 and 27020. So before you connect, you have to traverse to the bin folder, and that's where I have copied my. So let me just. And then I have to connect to the secondary that is running in port number 27019. So it starts, and very well, when it connects, it says it's secondary. So we have configured a primary and secondary. We have inserted data from the primary. Is the data replicated here? So we have to go and see the databases available. Okay. Before doing any read operations, as I told you, we have to configure the secondaries for read. How you configure the secondaries for read is you have to run this particular command rs.slave OK. So only when you run this command, you can read data from the secondary. It's a configurational thing, whether you can allow data reads from the secondary. So let me just copy rs.slave OK. Say why we are having this configuration is, say it's a distributed log. Primary makes some changes, secondary may not be updated. In certain cases, you want consistency of your data, right? You may not allow reads from the secondary. But here, if you want to allow the users to read from the secondary, you have to run this command rs.slave OK. Now we'll go and view the databases, show DBS. So you see Satish DB got replicated here. And show collections, I created a collection to show collections. Use Satish DB. Yeah. We have to go to the database, right? And then we have to see the collections here. Yeah, we have the student collection, and then db.student.find should give me this record from primary. So it got replicated here in the second. So this is one of the secondaries. We have to connect to the second secondary too. Whether there too the replication has happened. So for that, we have to connect to MongoDB Mongo instance running at port number 27020, and I have to go to this bin folder. And how will I connect Mongo, and then I give the port number, and then 27020. So this is the next secondary, and we have to check whether this one, again we have to give this rs.slave OK here too, I guess, and show DBS, use Satish DB. So you can see that Satish DB got replicated here too. So show collections, yeah, db.student.find. So we inserted data in the primary, and that got reflected in the secondaries. The next thing that we have to understand is, can we really write data to the secondaries? Can I do some insert in the secondary? So this is the secondary. What I will do is I will just try to do this db.student.insert. Directly I will try and insert data in the secondary. Say name Satish, will try to perform this. It gives an error message. The error message is not master. So that's how this Replicaset works. So that thing we have understood. Are you all clear? Was I too fast? A very simple thing. How replication works. It happens automatically when you configure the Replicaset. We are doing it in the same machine. You can have different servers in different locations, and it's very useful. Now we have to look at failover in replication. That is when the primary goes down, whether a secondary becomes primary automatically. That we have to check. So what we have to do is we have to go and shut down the primary server. We have a process for that. You go to the primary, you go to the admin database, and then you invoke this command db.shutdown server. So let's go and shut down this primary. Let's look at where primary is running. Yeah, this is the primary, and we'll go and view the databases. Here you have to go to this admin database, and we have to give this command. We'll shut down the server. Yeah. Let me just say. I think this is down. Server should be down. The message we are getting. So now we have to go to our secondaries. Let's check whether they went in for an election. Did they do something? db.student.find. Let me run some queries here. And let me check the another. We'll close this primary. We don't need this anymore, right? We'll check the other two secondaries. Whether they are changing their status. That you have to check. See now, this secondary changed to primary, automatically the election happened. Now I can go and insert data from here because now this is the primary. Do db.student.insert and then you can see name from new primary. You will say that. Okay. See, now we can insert from here and we have to check whether this is reflected in our then only secondary that is alive. db.student.find from new primary. Yeah. So that is how a Replicaset works in MongoDB. Okay. I hope this demo gave you some insight on what this Replicaset means. Okay. Are you clear with what is a Replicaset? It's nothing but same copies of data in multiple servers and fault tolerance is available. Sharding. This is a concept that is new to us. What is sharding? Let me give the definition. I'm not going to show a demo of sharding in today's class. It's a very big process. Maybe I postponed it to after CAT 2. But we'll learn what is sharding and the theory behind it today's class. Okay. Sharding is a method for distributing data across multiple machines. This is again confusing. We were copying data across multiple machines. Now here the definition changes. Distributing data across multiple machines. And MongoDB uses sharding to support deployments with very large data sets and high throughput operations. What is sharding? Let me again take this scenario that we learned, the application scenario we have learned, right? So the application writes to the primary, you all agree, and data only gets copied to the secondary. Now there can be a situation wherein your data can grow to a very large extent. You keep on writing data and this can really be a strain on this one server that's running. You keep copying, but this can really be a strain on this server. So how to handle that huge data that comes in? How to do that? So this is the thing. Database systems with large data sets or high throughput applications can challenge the capacity of a single server. Though you have 3 copies, you still have one single server maintaining the entire data. So the CPU capacity may get exhausted. The RAM capacity will be a stress on the RAM, and IO also will be a problem on the disk drives. So in that case, we have to think of some solution here: vertical scaling and horizontal scaling. We have discussed this in the very first class. What is vertical scaling? I'll go and increase the RAM size here. I'll go and increase the hard disk capacity there. I'll just try to somehow increase the capacity of my one single server so that I can accommodate this increase in my data. But that is really challenging, and you cannot increase the capacity of the single server beyond a certain extent, right? There are some technology limitations or constraints. I can't go on adding RAMs or hard disk in parallel. So what we do is we go for horizontal scaling. Horizontal scaling is nothing but instead of having this single server, I just go in with many more servers. So instead of having the entire load on one server, I'll distribute the data or the workload among different servers. So that becomes sharding, and I have got a visualization of sharding, and that comes under horizontal scaling. Whenever the workload on a server increases, I'll have multiple servers and distribute the workload. So what is sharding? Now instead of one single primary, I have multiple servers. And I call this shard 0, shard 1 and shard 2. We have a routing server that will actually route data to these shard servers. So now, say we have many documents. We consider this to be a document from applications. Lot of document coming in, and this will be going to the routing server. In this routing server in MongoDB is called MongoS. It's a query routing server, which will route the data. Say data 1 will go to a particular shard, data 2 will go to a particular shard, data 3 will go to a particular shard. So data gets distributed, not copied. So this will hold some pieces of the data, this will hold some of the documents, and this will hold some of the documents. A collection itself, when it's becoming very huge, it can be distributed across different. Okay. So what you call these things to be shard servers. These are shard servers. This is the routing server. and that will be dealing with the applications. Okay. Because as an application, when you write data, you're not worried about writing to which shard. You just populate the data. The routing server will take care of distributing the workload among the servers. Again, each shard can have replication. So you have data 2 here. This data 2, replica server 1, replica server 2. These three things become a replica set that we have just now learned. It's a replica set. Why we go in for this? If the server fails, we lose data 2, right? So we go in with replication of data 2 into other servers. So if this fails, this becomes the primary, still answers and performs the workload. Likewise, when the shard 1, we can have replica sets for this. So this becomes a replica set, and this becomes a replica set. So we give fail-safe options for all these workloads that we have distributed. So like that, we can have many shards and we can have almost 50 replica sets. One problem here is the routing server, how it will know to which particular shard this collections document is. It should have somebody to support it, right? So it needs a configuration server. The configuration server will hold the metadata for the cluster, like, okay, this document, this shard holds this data. And routing server will refer to that and help. Now the question comes, if the configuration server is again a MongoDB instance, if this goes down, your entire cluster goes down. So what they do is they have a replica set for configuration server too. No matter how whatever you do to this, will not fail, will always be up. So that's why it becomes a very complex architecture as such. And that's why we are with NoSQL databases. And you understood the basic architecture behind sharding and how data gets split across different shards. You would have learned this in your previous semester on different partitioning techniques like hash-based partitioning, range-based partitioning. If you have learned partitioning seriously and if you have seen the demos, you would have seen how partitioning happens. The same kind of a thing we have a shard key, we use that key, we partition data, we push it to different shards, or else we do range-based partitioning wherein we take a range of the shard keys and then we hash it and store it in different shards. We'll be looking at all these things again in the next class. But to go with a few definitions, a shard, what is a shard? It contains a subset of the sharded data. Okay. Each shard can be deployed as a replica set. You all agree with me on that. If I have not shown that visualization, you will not have agreed with me, I guess. MongoS, what is this? MongoS is the query router. So it provides an interface between client applications and the product cluster. Now from the Mongo shell or the application, you'll be only contacting the MongoS query router. What are configuration servers? They hold the metadata for the cluster. And this is important, after MongoDB 3.4 version, it is mandatory that your configuration server is also a replica set.